Welcome again. Now it will be our last video for this lecture, and it will tackle about dimensional analysis, which is also known as the factor label method or the conversion factor method. So we will be changing one measurement into another, either by adding a prefix or into another unit system or into another unit but the same system. So there are only two steps on how can we do it. So first we need to identify the units that needed to be changed and the units that you need to arrive with. Lastly, we need to um, deal with conversion factors to cancel out the initial units and perform the operations, and we need to use a scientific calculator as well. So this video will be mostly not about how can how can we memorize the steps, but rather how can we do the computation. So first, we have here an example. The label on a box of a cereal gives the mass of into units. So 978 grams and 34.5 ounces. Use this information to find the conversion factor between English and metric system or metric units. So it is actually a very different type of problem, but it is a very easy one. It's just that we need to find out um, the conversion factor. So how can we find out? First, we need to equate those two units. So we have 978 grams and 34.5 ounces. So what is a conversion factor? The only thing you need to do in a conversion factor is divide one side of the equation of this equation to another so that the other side is equal to 1. So since 978 is larger than 34.5, let's just divide the smaller one so that we will be ending up with a whole number, or rather a number greater than 1. So 978 grams over 34.5 ounces is equal to what? So by using our calculators, our scientific calculators, so we have 978 divided by 34.5. And the answer is 28.3 grams per ounce per 1 ounce is equal to 1. So what does this mean? So we already arrived in the correct answer. But what does this mean? It only means that for every ounce of cereal, for every ounce of cereal, there will be 28.3 grams of cereal. So it is just used to have a different unit system. So we have here an English system and a metric system, or the USCS and the SI unit. So proceeding uh, to another problem. Many chemistry conferences have held a 50 trillion angstrom run. How long is this run in kilometers and in miles? So we already have a conversion factor here, which is very easy, meaning the only thing that we need to do is first identify our First is identify the given, which is 50 trillion. So that is 50 times 10 raised to 12 angstrom. So you can use your prefixes as your reference for, or the list of prefixes as your reference in this type of problems. So as you can see, 50 trillion or 50 times 10 raised to 12 angstrom. So first, we need to arrive on a measurement that we want. So the measurement we want is in kilometers. So to be able to have kilometers, we need to cancel out the angstrom. Meaning, based on this conversion factor, we need to multiply a conversion factor where the denominator is in angstrom. Meaning, it should be 1 times 10 raised to negative 10 meters over 1 angstrom. Why is it so? Because we want to cancel out the angstrom. Next, we are not in kilometers yet. So, since we have a meter on top of the angstrom, we want to cancel that out. And we want a kilometers above so that we can cancel the meters and left with kilometers. But how many meters are there in 1 kilometer? Or how many kilometers are there in 1 meter? So in 1 kilometer, there are actually 1,000 or 1 times 10 raised to 3 meters. So we can now perform the following operations. So these are just multiplication and division, as you can remember. I just use a tabulated format so that you can see which are on the denominator, which are in the numerator. So we need to calculate this using a scientific calculator, which means that 50 times 10 raised to 12 times 1 times 10 raised to negative 10, and then divided by 1 times 10 raised to 3. So our final answer is 5 kilometers. Thus, we already converted it from angstrom to kilometers. So that's how we use dimensional analysis in performing calculations. Let's try it out again in another example. As an instructor is preparing for an experiment, he requires 225 grams of phosphoric acid. The only container readily available is 150 milliliters of Erlenmeyer Plus. Is it large enough with the density 1.83 grams per milliliter? So this is actually an analysis problem which involves dimensional analysis as well. So as you can see, this one is actually our conversion factor already, this one. So for every milliliter, we have 1.83 grams of phosphoric acid. So we will use this, um, we will use the density a as our conversion factor. So 225 grams. So how can we cancel out? So we just need to raise this one, our density, to negative 1. So 1.83 will be going on the denominator, and 1 milliliter will be on the top. Then we just cancel out the grams and perform the calculation. 225 divided by 1.83. So our answer is 122.95. But since it is already in three significant figures, so our final answer is 123 milliliters. So by just comparing it with 150 milliliters, it is very obvious that 123 is will fit on 150 milliliters. There's an allowance. So last on our um, let us try to change the measurement to make or change the unit of its prefix by changing its coefficient or by to arrive with a whole number, or just let's try to make this 1.93 times 10 raised to 4 into kilometers. So first, let's make another slide. So we have 1.93 times 10 raised to 4 meters. We want to change it into kilometers. So as we all know, 1 meter is equal to 1 kilometer. I mean 1 kilometer is equal to 1,000 meter, or 1 times 10 raised to 3. So we will just need to have a conversion factor where the meter is on the denominator. So obviously we will just divide 1,000 on both sides. There we go. So 1.93 times 10 raised to 4 meters. Don't forget your signs or units. Then multiply it by 1 kilometer. Wait. Time over 1,000 meters. Then we will already arrive. We will cancel out the meters. We will left with kilometers. And the answer is obviously 19.3 kilometers. So that ends my lecture on our very first lecture in Chemistry Core, and I hope you learned something. If you have more questions or you have queries about this topic, I am very welcome for your queries in Facebook Messenger through PM. Thank you and have a great day.